let's talk about the chainer, okay? Well, we talked about productor and quotient before, right? Now we're gonna talk about chainer, okay? But you know what? Like, I can tell you the chainer is the most important rule in this course, okay? So which means that without this one, there is no way to pass the course, okay? So you have to try to understand this one very, very clearly, okay? So, well, because as I told you, even we learned about productor and quotient, and I gave you one combined one, right? But like in future, I mean, like it's just like after 1 or 2 weeks later, and you will have like, like function which is combined product rule with chainer, or quotient rule with chainer, okay? Or product, quotient, and chainer. Chainer will be everywhere, okay? So you have to try to understand this one very clearly, okay? So look at that. So let's try to talk about the function form first, okay? Look at that. This capital F function. Can you see it, this one? Capital F is equal to f of g of x, okay? So your chainer is working whenever you have like your functions are wrapped, okay? So let me show you again, okay? Let me rewrite your function f of x, okay? F of x with different color, okay? F of g of x, okay? Do you know why I'm trying to use like 2 different colors? Because I would like to show you like the layers, okay? And g is inside function and f is outside function. Does it make sense? So whenever I explain this chainer, okay, I always like explain like this way, okay? Whenever you take the shower, you have to take off your clothes, okay? But think about it. Well, like, like, did you ever like try to like take off all the clothes at once? I did before, but like in this world, it is illegal, okay? So whenever you want to take off your clothes, you have to take off your clothes from the outside to in, okay? For example, like if I assume like I have like jacket, and you have to take off your jacket first, okay? Then take off your t-shirt and underwear. Don't imagine anything, okay? But anyway, the important thing is like a layer by layer, okay? So this like capital F function, there are 2 layers, okay? Jacket function F, which is outside function, and t-shirt function G, which is second layer, okay? Then when you take the derivative with respect to x, what happened? It is here. Look at that. F prime is equal to F prime, which is jacket function, outside function prime. Then whenever you take up your jacket and don't touch your inside, okay? That's why G of x is inside here, okay? And then multiply G prime, which means take up your t-shirts, okay? So layer by layer, okay? So let me give you one more, okay? So in this case, we have only 2 layers, right? But if your function capital F has 3 layers, then what are you going to do? Is equal to f of first layer, jacket function, second layer, t-shirt function, and then third layer, underwear function. Is that okay? Then f prime x, or in a Leibniz form, df over dx is equal to layer by layer. Take off your jacket, which is at prime. That's it, right? Then rewrite your inside. Okay, let me use just same color, okay? G of h of x. Then t-shirt prime. Take off your t-shirts, okay? And then keep that in mind. When you take off your t-shirts, don't touch your underwear. And times h prime, which means take off your underwear and take a shower, okay? This is chainer, okay? So like for chainer, you have to count how many functions are wrapped, okay? Then take the derivative like step by step, okay? And also I strongly recommend to use like different color pencil, okay? Then you can easily figure out what you are doing, okay? Let me give you a couple of examples, okay? Look at that. So first of all, you have to realize like there are a layer for this function, okay? Function f is 4x squared plus 7x to the 5. So like, your power 5 is outside function, and 4x squared plus 7x is your inside function, 2-layer function, okay? Then we're gonna apply the chainer, okay? Here we go. So f prime x or in Leibniz form, df over dx is equal to outside layer. It is power function, which means we're gonna follow the power rule, right? 5. That's it. We done the jacket function prime, which means outside the function prime. Okay. Then what are you gonna do? As I told you, when you take up your jacket, don't touch your inside. Don't touch your inside. Then once you write this one, you have to multiply that second layer function prime, which is 8x plus 7. That's it. You have to stop here because we have only 2 layers. Is it okay? And what about b? Well, we would like to use the quotient rule, but I don't want to do quotient rule. How can I do it? If you write this one as negative power, it is simple chain rule, right? Here we go. It is equal to, let me rewrite this guy as with a negative power, okay? It is equal to x squared plus 5x plus 4 to the negative 10. Is that clear? Then, what is g prime? Definitely it is chain rule, right? dg over dx is equal to, outside function is power function, right? Negative 10 out, and then negative 11, because I just subtract 1, right? The first one, okay? Then just pause. Then we're gonna write the inside function, okay? X squared plus 5x plus 4. Then once you write the inside, then multiply your teacher's function prime, 2x plus 5. That's it. This is the derivative function, your g. And or if you don't want to have like negative power, yes, you can do that, okay? Just like you can move like your negative power part as your denominator, okay? But again, it is just an option, okay? Here we go. So if you want to do like that, you can write this one as negative 10 times 2x plus 5, which is numerator part, over x squared 5x plus 4 to the 11, okay? Either way, it doesn't matter. Let me give you a couple more examples, okay? So look at C, okay? Like there are 2 parts, sine 2x plus cosine 5x squared, okay? They combine by plus, which means separate function, okay? But look at sine 2x, okay? 2 layer, sine function and 2x. Second function, cosine function and 5x squared, okay? Just like a 2 layer chain rule problem for each of them, right? So what is f prime? Which is df over dx is equal to first function, sine prime, which is cosine of inside function. 2x itself is inside function, okay? Then multiply 2x prime, which is 2. That's it. We done the first part, okay? What about second part? Cosine function is outside function, and cosine prime is minus sine of inside function, okay? So let me use different color for inside function, okay? It is 5x squared. Then you have to multiply 5x squared prime, which is 10x. That's it. This is the function derivative, okay? And what about d? It's also easy, right? 2 layer function, right? Tangent is outside function, and cosine is inside function, okay? So g prime x, which is dg over dx, is equal to outside function tangent prime is secant square of inside function. Pause. And then once you write the inside function, don't do anything for here, but you have to multiply inside function prime. This is chain rule, okay? What about this problem, function h? Can you count how many layers do you have? It's a little bit complicated, okay? How many layers? 1, 2, 3, and 4. So this function is 4 layers, okay? So let me show you like with the power form. The square root is 1 at power, right? So the most outside function is this guy. Second layer, or teacher's function, is cosine. Are you with me so far? Then third layer, or underwear function, is not sine, but square, okay? This is the way to write your sine square function as like in trig function, okay? So it is this guy. That is third layer. And the first layer is your body, skin, whatever, I don't know. But it is sinus. Keep that in mind. 4 layers, okay? So you have to do like 4 times chain, okay? So writing answer is like quite easy. Here we go. H prime x is equal to, or dh over dt, right? dx, right? Okay? Then what is that? Most outside function, power function, 1/2 power function prime, which is 1/2 negative 1/2 because of we subtract 1, right? And that's it. This is outside function, jacket function prime. You take up your jacket and second layer. But you know, as I told you, whenever you take off your jacket and you have to keep, you do not touch inside, right? So we're gonna rewrite your inside like that. And then second layer, cosine function prime is minus sine. That's it. Number 2, right? What about third layer? It is square function, right? Square prime, and I told you, like whenever you take off your t-shirts, and don't touch anything inside, right? So let me rewrite this guy. And then third layer, square prime, 2. That's it, to the 1, right? And then let me write the first layer. And then multiply first layer prime. That's it. This is 4-layer chain problem, okay? So what about problem F? Well, can you figure out which is outside and inside? Just 4 is just coefficient, so like you don't have to worry about it, okay? Just so we're gonna keep writing 4 in front, okay? Then what about the first layer of this function? It is exponential function, e, okay? Then your inside function is sine x, okay? Well, if you have any chance to do the computer programming, and this might be really it makes sense, okay? Because whenever you have to type exponential function in computer, then we write like this way. Like that function can be written by like this way in computer. 4 times exponent and sine x, okay? If you rewrite like this way, it is obviously, exponential function is outside function and sine x is inside function. Does it make sense? Okay? So anyway, so let me try to do 2-layer chain, okay? So f prime x or df over dx, right? Is equal to 4 times e to the x prime is e to the x, right? E to the inside, right? This is first layer prime, okay? Then what about inside? We have inside function. Then once you write inside function, you have to multiply that inside function prime. That's a 2-layer chain of problem, okay? Okay, what about this exponential function? It is different with e to the x, right? If your base is e, we know e to the x prime is equal to e to the x, right? But if your base is not e, but different number, but don't forget you have to multiply ln b behind of b to the x, okay? Well, with the change of base of exponential function, we can easily prove this guy, okay? But in this class, we are not going to show you how we can prove this one, but you have to remember this, okay? So for example, 2 to the x prime is equal to 2 to the x times ln 2. Does it make sense? Well, even your base is e, it can be applied, okay? E to the x times ln e. But since ln equal to 1, that's why we can say e to the x, okay? It's same thing, okay? But keep that in mind. If your base is not e, then you have to multiply ln of your base behind your exponential function, okay? So let me apply this one to here, okay? Here we go. So function f of t is given 2 to the t cubed, okay? As I told you, 2 to the power is your outside function, and t cubed is your inside function, okay? So let me notate like this, okay? T cubed is inside function, okay? Then what is f prime t? In a Leibniz form, df dt, right? Is equal to outside function, which is in 2 to the power form, is 2 to the power times ln 2, right? And you know why I just paused without writing your inside, right? because we're going to do the chainer, right? Your inside function t cubed, once you write the inside function, you have to multiply inside function prime. That is chainer, okay?